All right, hey guys, welcome back to math. We're going to start a new unit today. It's in chapter 9 of your textbook, and it's called Analyzing Graphs of Linear Relations. So basically, what we're doing is we're actually looking at a ton of graphs this unit, but we're actually building a skill that's being utilized next year in grade 9, but then in grade 10, it's about half of your grade 10 year, and then it's a skill that you use all the way through grade 11 and grade 12 math. So this is a very, very important unit to really listen to the video, to actually kind of, try to get what's going on. And a lot of it has to do with patterns and building formulas for straight lines. So I'm just going to start off right here, and we'll take a look at the notes. So the first thing we need to do is we need to remember graphs. And so, yeah, we did that a long time ago. But here's the biggest thing. We need to remember that there's always a y-axis and an x-axis on a graph. And the x-axis is always the one on the ground. And the y-axis is always the one running from top to bottom. So when we look over at this graph right here, we notice that there's an x-axis here, a y-axis here and an x-axis here. And so the x-axis is on the bottom, and it has to do with the number of toppings that they put on pizzas. And when we look at the y-axis, which is the one running up and down, we notice that it's going to talk about how much it would cost depending on how many toppings you got on your pizza. So this graph has an x and a y-axis, and we need to remember how to graph coordinates. So basically, if we go kind of down here, we have to make something called a table of values. And so that, however we do that, we always are going to put the x first and then the y second. So there's two ways that you'll see it. Sometimes you'll see it where it's a vertical chart like this, and sometimes you'll see it when it's horizontal. Either way, the x always comes first and the y always comes second. And then you write your nice coordinates into them. These right here are coordinates 1 and 5. If we look over here and take a look at what's going on over here, building graphs using coordinates, we can take this data, the x and the y data, 1 and 5, and we can build something called a coordinate. And so if you remember from grade 7, you always plot the very first coordinate and you look on your x-axis first. So you go to the 1 on the x, which is right here. It says that we need to go 1, so we start here, and 5. And so we make this little triangle, and that's where we would put our dot. The next coordinate here says 2 and 10, and that's the same as we find it on our nice little table of values. 2, 10. So we start with 2, we go up to 10, and so we plot this this little dot here, and we continue to go through and plot. And what you're going to notice in this unit is that what we want to build is a straight line, because that's what we call a linear relation. And so that's a weird word to put it, but a weird way to put it, but basically that's what it means, making a straight line. So that's just a reminder on x-axes, on y-axes, on how to plot data onto a graph by using a table of values and making sure that you make this chart, making sure the x is always first, the y is always second, remembering that these two things make something called a coordinate so that we can plot it onto a graph, and then we're trying to build a straight line. So now we're going to kind of move down here into some of the examples. So here we go. Example 1, it says this: make a table of values from a graph. So a table of values is what we just did back up here. So they want to do that. It says the graph shows the total cost in relation to the number of baseballs you buy. So looking at this graph, guys, if we take a look on the x-axis, it's the straight line on the bottom, it's relating to the number of baseballs, and the y-axis up here is pointing, and that's the total cost of those baseballs. So you'll notice that there's some dots on this graph creating a straight line, which is fantastic. So the first question says, A says, describe the pattern that you see on this graph. The pattern is the very, 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 very most important thing that we're going to do in this unit. So to find the pattern, you can do two things. So the first way that you can look at the pattern and find it is literally by just looking at the graph and see how much it moves by every single time. Sometimes the graph moves down and sometimes the graph moves up. You know that the graph is going up if it's going up to the right-hand side. That means it's going up, and you know that it's going down if it's going this way. But we don't have many of those graphs to worry about right now. So our graph is going to go up by a certain amount. So I'm going to look at this over here. I'm going to just make the graph bigger again. And the first thing I'm going to do is just look at the graph. So guys, when you take a look at this, you're always going to start here, the 1. And so this y-axis is at number 3. So this is where the dot is at 3. If we look at the next dot, it's at number 6. So 3 and 6, I'll just write that here. So this was 3 right here, and this is 6 right here. So you notice that I did that right there on the graph from 3 to 6. I made sort of this thing called a triangle pattern, and I'm just basically going over 1 and moving up 3. And so I know that from 3 to 6, you got to add 3 to get there. And so let's take a look at the next one. This dot's at the 6 here. This dot's at the 3 here. What is this dot at? Oh, it's at the 9. Hey, guess what? That's another plus 3. 6, 7, 8, 9. And then if we go up to this dot right here, we can take a look. It's at the 12. So hey, guess what? 9 plus 3 is 12. So the pattern on this graph is plus 3. That's how we determine the pattern from the graph. There's another way that we can actually look at the table, and that's by using that's by using a table of values. And this is the way that you have to do it in high school. This is the way you have to do it in grade 9. This table of values way, to me, is the very, very best way. But if you can tell from the graph, no problem. It's going to be quite simple because you're going to be able to find out. So how do we find the pattern? 1, we could look at the graph. 2, we're going to build a table of values. So here's our table of values right here. Now, just going back up here, what I'm doing is I'm actually just graphing and putting the coordinates of each point to make a table. Remember that this down here is the x-axis, so you start with that. So the dot's here, so it's at 1 and 3. So 1 and 3 is your very first coordinate right there. And then I'm going to go back and do it again. There's a dot here. I'll just do it in red here. And so it's at the 2. So it's 2 and 6. So that's what I write right here, 2 and 6. Same thing, we go to the 3, we notice that it's at the 9, so we will write 3 and 9, and then the last one's at 4 and 12. So then it's actually a lot easier to notice a pattern in a table than it is to notice it in a graph, I find, because I can just look at these numbers right here and say, oh, this one goes up by 3, this one goes up by 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. So I found the pattern to be plus 3. Fantastic. Super important. If you can do that, then this math's going to be easy. So question C says, if the relationship continues, what is the cost of 14 baseballs? Okay, guys, I want to just mention here, we only went up to 4 baseballs. Can you imagine having to draw this whole graph out all the way to 14? It would be way out here, and your dots would go way, way, way up there. And so some people try to do that without understanding the math I'm about to tell you, but I'm going to tell you right now that's a brutal way to do it. So look you can sometimes extend this table right here, the table of values, to determine the next pattern only if it's easy and it makes sense. So right now they're asking for 14. Okay, we're at 4. That's a boatload of drawing out the pattern or making a really long table. Can it be done? Yes, but mathematically, it's not exactly what we're looking for. It doesn't get us to that grade 9 or grade 10 or grade 11 place. We want to build something called a formula. But right now, if I said how much does it cost for 5 baseballs, or if I had to just put a 5 there, well, that's super easy because the 5 is the next number, and all you got to do is add 3 and you'll get your answer. So as you notice right here, this makes sense to just do in your mind or in your brain or looking at the table because the 5 is just right here. So we know that all of these, the pattern is plus 3. So if I just added 3 more, I'd get 15. So I would know that it would cost me $15 for 5 baseballs. But that question up above was asking for how many it was for 14 baseballs. And this is where you need to really, really come with me and understand how this works. Making formulas from graphs and tables is literally what math in high school is all about. This is your introduction to building those formulas and looking at them like they're formulas. You've actually seen this in grade 6. I know you've seen this before, but this is really literally the part where our brains come and we start to put everything together. So guys, linear equations always make straight lines, and I already told you that. And in math, we always write linear equations like this. Y equals something x plus 4. That's grade 9 and grade 10, but I think for now we're going to stick with this one until we get a little bit better at it. So we're going to just be like y equals 3x. Below I've shown you a picture of each of these graphs. This graph, when you put it into a graphing calculator, looks like this. You'll notice it's a straight line, and this number here, this number 3, indicates the slope of this line. So what a slope is, sorry, I'll just draw this. If you were to ride a bike, oh boy, yeah, okay, yeah, oh yeah, okay, cool. So that's my bike. Awesome. Okay, so if you're riding a bike, the slope is basically how much of an angle this dude's got to climb up the bike. All right? And if we look over here, y equals 3x, this is the graph that the line gives here. The same thing, this is the same slope as this bike rider guy up here. It just goes through a different number on the bottom. You'll notice that this one here goes through the 4. And if you want to know something about grade 10 and grade 9, we learn that that's that secret right there. But right now we're just dealing in y equals 3x. So the line always will go through 0 and it'll be a beautiful straight line. Anyway, so that's a linear equation. Something to think about, nothing to worry about if you don't totally get it, but we're going to start writing an equation. And your equation is always going to start with the letter y. Y equals, you're always going to write that down. It's just going to become something that we're going to do because we're going to get really good at writing this. Then the next number that you're going to write down is the pattern number. So that's super easy. We found that the pattern was plus 3. So we're just going to write y equals 3x. This equation is actually this line right here, and that is how you build a linear relation. So cool, all we needed was the pattern. So we didn't need to overthink anything else, but we needed to get a table, we needed to find the pattern, and once we did, bam, we found the answer. So guys, check this out. This is the pattern number, the 3 right here, okay, plus 3. The x value, this x, refers to all of these numbers that we could throw in there if we wanted to. And over here, this y refers to this column right here, all of the y numbers. So again, pattern, x is here, y is here, okay? Cool. So we can actually get a whole bunch of answers by filling in the blanks for the x's and the y's. So our formula, it was simple. We just wrote y equals the pattern, which was 3x. Bam, that's the answers. Because we built this formula from our table, we can figure out any information that we want about the graph above. That's what we want to know. So I reposted the question again, and this is the one we're solving. If the relationship continues, what's the cost of 14 baseballs? Now, for some of you, if you didn't listen to anything above, you're going to make a table that's 14 things long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You're going to do the math succinctly, and you're going to put plus 3, and you're going to plus 3, plus 3, plus 3, plus 3, 14 times and hope and cross your fingers that it's right. But that's not how we do the math anymore. We're going to use our formula. So here's how we figure out how much the cost is of 14 baseballs. The first step was to make a table. Ours was already done, so I drew it right here. That's your first step all the time. Step 2 is label the x-axis with what they are on the graph. So you'll notice in purple here, I've done that. My x here was number of baseballs. See that? So I wrote baseballs on the top. The second thing is that your y-axis was total cost. So I wrote that on top in purple of my y. The third step was we already did it. Find the pattern. Easy peasy. It was just plus 3. And we knew that because 3 plus 3 is 6, 6 plus 3 is 9, and 9 plus 3 is 12. Step 4 is write the equation. So I already told you how to do that. Remember that you always write y equals the pattern, which was 3, and then we write the x. Now, step 5, check the question. What is the cost of 14 baseballs? We need to look at this part in particular. Was the baseballs on the x-axis or was it on the y-axis? We have to ask ourselves the question. So when I go back here, I notice that I wrote baseballs for x and total cost for y. So that's why I wrote baseballs right here. I want to know if I stick 14 into the x, what the answer will be for the cost. So step 6 is to insert the value into the x, or the y spot. In this case, we had the x value because we were talking about baseballs. So I'm going to stick the number 14 where the x is. And so that's what you write right here. Y equals 3 times 14. Step 7 is solve your equation. So all I have to do is go 3 times 14, I get 42, and guess what, guys? It's $42 for 14 baseballs. So being able to actually plug numbers into our letters is really important, and that allows us to not have to make tables that are like 20,000 times long. So that's super important. All right, guys, so we're going to do a show you know. So what I'm going to say right now is if you want to just pause the video and actually answer these questions yourself, you'll give yourself real confidence to be able to do the homework that's due for this week. Otherwise, you can follow along with me for the first example because we're actually going to do 2 examples. So give it a try, pause the video now, answer the questions by yourself, see if you can do it on a separate sheet of paper, and if you want, you can sit and listen or come back and check your answers. That's what you want to do. That would be the best way to do this. So I'm going to give you a sec, pause it, and try to figure out these answers under the show you know. All right, so I'm going to do the answers now and walk through what they were. The graph shows the number of triangles in relations to the figure number in a pattern. So triangles in a pattern. Okay, so if you have figure number 1 had 3, figure number 2 had 6, figure number 3 had 9, and figure number 4 had 12. Describe the patterns you see on the graph. Okay, well, let's use the graph. So I'm just going to write A here to figure out what we went up by. So we started at 3, and the next one was at 6. So this one actually seems like it has the same jump that the last one had. 3 plus 3 is 6. 6 plus 3 is 9, and 9 plus 3 is 12. So the pattern that I saw in the graph was plus 3. That's all you have to write there. Draw a triangle pattern that matches the graph. Okay, so it wants me to actually draw the pattern here, and this is kind of weird, but it's just basically saying that in figure 1, we're going to have 3 triangles. So I'm going to draw 3 triangles like this, just because I like doing it like that. In figure 2, it says that we need to have 6 triangles. So I'm going to go 1, 2, 3, 4, 5, 6. Figure 3 has 9 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. And figure 4 would have 12. And so that's how you would draw your pattern that you saw, going from 3 to 6 to 9 to 12. Then it says, make a table of values from the graph. Okay, well, we've already talked a lot about that, and we definitely can do that, no problem. Remember that your x is always going first and your y always goes second, and we're going to draw the coordinates. So we start on the x-axis, and we go over to the 1, so that's our first number here, x is 1, and then we go up, and we hit our 3, so it looks like y is 3 there. We do the same here. Here's the dot, so it looks like our x is 2. Oh, sorry. And this was 1 and 3. 2, and I go across, and 6. 3, 4. So it would be 4. Oh, sorry, 3 and 9, and 4 and 12. So that's the table of values. And then if the pattern continues, how many triangles are in figure 99? Oh, you guys, this is where you just can't draw this. I definitely have had people in my grade 9 class try to draw 99 things and add the pattern over and over again, and it hasn't worked out very well. So before we go anywhere, remember the steps. Going back up here, we were supposed to label the x and the y with what they were. Oh, that's right. So let's just do that. This was the figure number, and the y was the triangles. And then the second thing, or third thing, sorry, that we had to do was find the pattern. So I'm going to find the pattern just by looking at this. And you go to your y only, okay? You're looking at your y. You're not looking at anything else. So what was the pattern? Well, I can see here that you added 3. So the pattern was 3. So how do we write our formula now? So you always start by going y equals, okay? Then we write the pattern number, which was 3, and then write the letter x. 3x. That's our formula. So I want to know how many triangles are in figure 99. Looking here, we notice that the figure is the x. So basically 99 is down here. And so all I need to do is insert the number 99 in the x place to get this answer. Y equals 3 times 99. And when I do the math for that, it's going to be, just to double check here, 3 times 99 is 297. So there's going to be 297 triangles in figure 99. Cool. So that's how we do the first problem. The second problem says Chad's buying a notebook at Bob's Bargain Store, and the graph shows the cost of a notebook. Describe the pattern you see on the graph. Okay, here we go back to the graph. So the first point looks like it stops at 2. The next one stops at 4. The next one stops at 6. And the next one stops at 8. So we know that our pattern is +2 on the graph. All right, cool beans. So B, what is the cost per notebook? How do I know? Okay, so the cost per notebook looks like it's going to be for one notebook here, because this is the number of notebooks. If you buy one notebook, it's going to cost you $2. So I know that the cost per notebook is $2. I also know that because it's the pattern number, and every time they buy it, it's going to go up by $2. C, make a table of values from this graph. Okay, so guys, same thing, x in the front, y in the back. Moving, first write your x values. You've got 1, 2, 3, and 4. 1, 2, 3, and 4. And let's take a look at the coordinates. 1 and 2, 2 and 4, 3 and 6, 4 and 8. Cool beans, Batman. Then it says, is it possible to have points between the ones on the graph? So guys, is it possible? This is a good question. Actually, before we even get to that question, can we just write the formula for this? Because we would find the pattern, right? And then our formula for this would be y equals 2x. Because this is the pattern number, and then we'd write that. And that would be your beautiful formula. So the last question, is it possible to have points between the ones on the graph? Yes or no? Well, here's the biggest question. Can you buy 1.5 of a notebook from a store? No. So the answer is no. You can't buy partial notebooks from the store. So we actually couldn't have a point in the middle. Sometimes we can because it makes sense on the graph. Sometimes you can't. So just make sure that you're thinking through, does it make sense? Could I buy part of a notebook and spend money on it? No. Chapters ain't going to buy you, let you buy like half a notebook. So the answer is no. So this is basically what we're going to do for our first part. And we're going to build these simple formulas and figure out the answer. So thanks for watching, guys. Make sure that you understand this stuff real well, because we're going to get a little bit deeper into graphs next time.